So if we take a look back at our vocab chart, we've got two new terms that we're going to take a look at. So translation we covered in 9.1. Now we're going to talk about a reflection. Can I get a volunteer to read out the definition of reflection? Go for it, Tina. Read that last part in the parentheses real quick. Just like a mirror. So it's a type of transformation. This is our second type. That now instead of sliding a figure, it flips a figure across a line. Just like a mirror. Now, if you're wearing an Edward Harris PE shirt, right, and you look in the mirror, what do you notice about the letters on your shirt?
Edward Harris.
They're backwards. Can you read it?
Yeah.
Well, I mean, you can read it if you imagine, you know what it says, so of course you can read it. But the words appear backwards, right? That's kind of how we want to think about this. Delaren, go ahead. Can I get a volunteer to read out what a line of reflection is? Ida, go ahead. Perfect. The line in which an image is reflected across. All right, so if you are standing in front of a mirror, that mirror is the line of reflection. If you were to reach out, let's say you're standing in front of a mirror, right? Imagine you're in front of your mirror at home, and you reach your hand out and you touch the mirror. What do you notice when you do that?
It's cold.
It's cold, okay. Fair. Like your fingers connect, right? They touch. So take a look over here or actually, like let's say here's your finger, right? You're putting it towards the mirror. Boom, your fingers touch. What happens when you take your finger away? They disconnect. They get further and further away, right? So that same kind of mechanic that we see when we're using a mirror in the real world is how we want to think about performing a reflection on a graph, right? So, let's focus up, please, so we can get through this in a timely fashion, so you have time to work. As always, let's start with just a singular point. We're going to reflect point G. What are my coordinates here for the pre-image point G? -2, +3. -2, +3. And we're going to graph the image of point G after a reflection across the x-axis. Is the x-axis my horizontal or my vertical? Horizontal. So what I want you guys to do, I forgot about this. Let me pass out some highlighters. I want you to take a moment once you get your highlighter and highlight the x-axis, just like that.
We don't have highlight.
You can put them back in your supply box once we're done with notes so that the next class period has them. Go. Sorry. All right, everyone's got a highlighter now, yes? Okay. Here's how we're going to do that. We can imagine that this point G is your fingertip. Here's the mirror. So if you're holding your fingertip 1, 2, 3 inches away from the mirror, on the other side of that mirror, it's going to be reflected equally. So we're going to go from point G. The first thing we need to do is count the amount of spaces from the pre-image to the line of reflection. My x-axis is my line of reflection. So I'm going to count 1, 2, 3 spaces until we hit that line. All right? Stay with me here. 3 spaces away from that line. Now we're going to count the same amount of spaces past that line of reflection and draw our image point. So now I'm going to count 1, 2, 3 spaces past the line. And I flipped my bumps to the other side just to signify kind of that we're mirroring this. And I'm going to draw my new point where we land and call it G prime. What are my coordinates for G prime? -2, -3. Great job. Doesn't seem too bad, right? Pretty straightforward. You got to identify what your line of reflection is. It's either going to be the x-axis or the y-axis. From your pre-image point, you're going to count the number of spaces until you hit that line, and you count that same number of spaces past that line. We want each of these points to be equally as far away from that line of reflection as the other. What questions can I answer about that right off the bat? Anything? Give me a thumbs up if that makes a little bit of sense so far. Okay. Makes sense to 6 people. Let's see if it makes sense to more after this. Let's reflect a line. We've got line HI here. Who's got my coordinates for point H? Where's point H at, Kimura? -4, -1. Perfect. What about point I? Ayana? -1, -3. You guys are professionals. I love it. Exactly right. We're going to graph the image of HI after reflection across the, now we're talking about the y-axis. So is my y-axis going up and down, or is it left and right? Up and down. I'm going to take a moment and highlight my y-axis just like that. Okay, so we know where our line of reflection is. We're going to go point by point, count the amount of spaces from the pre-image point to the line of reflection, count that same number past. Now this one's going to be interesting because we don't just have a point, we have a whole line. So we'll see something a little bit different happen here. Let's start with point H. Here's H. I'm going to count in what direction do I want to draw my bumps. Up, down, left, or right? Up? Take a look at my highlighted line. What direction should I go towards? To the right. We're counting towards that line of reflection. How many spaces? 1, 2, 3, 4 spaces. How many spaces are we going to continue to count in the right direction? 4. 1, 2, 3, 4. There's my new point H prime. We went 4 spaces towards the line of reflection, and then we went 4 spaces past the line of reflection. Halfway done. Now let's go to point I. We're still counting to the right. How many spaces are we going to count for point I? Well, let's just count. 1. That's it. We hit the line of reflection. So how many spaces are we going to count past? Just 1. Boom. There is I prime. We can connect those up and make our new line H prime I prime. What do we notice about this new line? Anything interesting? It's the same line. Yep, it is the same size line. It's the same shaped line. We changed our position, right, where it's actually at. And what else did we change? We inverted it. Good. We changed the orientation. Let me show you kind of like a visual way to think about this. Where's my thing? All right, I'm going to use a little transparent square here. So, here's my line of reflection. All right, there's point H, there's point I, there's my straight line. All right, there's H and there's I. Now, we talked about with the translation, we're just sliding that line around. We're sliding it up, sliding it right, sliding it down, sliding it left. But what we're doing here is we're taking this entire line and we're flipping it around like so. Do you see that? How we landed right on top of our new line, H prime, I prime. This is where we started. We're using this vertical line as our mirror. We flip it around completely. And we land right back there. And it's mirrored. It's inverted. They are sloping in a different direction, but they're still congruent lines. Okay, that's important. They're still the same distance. They're just flipped around and oriented differently. However you say that. So there's our starting line. We flip it just like that. Now, if we started here and we were going to flip over the x-axis, we'd flip it up. And it would look something like that. All right, so I think that's what we're going to see. No, we're going to do y-axis again, but that's okay. We'll get some practice with it later on. Now, we can't tell with the point that it's inverted because it's just a point. But now that we have a physical line to see, we can totally tell that we're mirroring our image across that line. All right, again, if this is your Harris PE shirt, this yellow line is the mirror. You've still got the same shirt, it's just inverted, flipped around, harder to read. Now my H prime is at 4, -1, and I prime is at 1, -3. Right? Questions I can answer about that? Okay. Finally, let's reflect a whole triangle. We got triangle JKL. Who's got my J coordinates here? Darius?
-4. No, yeah.
Yep.
And
-4, negative what?
2.
Perfect. Who's got K? Yeah, Ida? -2, 4. And L, Iona, Iona, yeah, go ahead. -1, -3. Sorry, Jackie, I thought you were raising your hand. Okay. I already did. Oh, you're going to let me know. That's probably for that group. Okay. Well, I don't know. You got them now. It's okay. So we're going to graph the image of triangle JKL after a reflection across the y-axis. Is that my vertical or my left and right axis here? Y-axis. Is that up and down or left and right? Up and down. So we're going to highlight the Y-axis just so we remember. We don't forget. We don't use the wrong axis here. Let's just start up at the top with K. If I'm here at K, there's my line of reflection. What direction do I want to start counting? If I'm starting here, I want to get to right here. What direction am I going to go? To the right. How many spaces to the right? 1, 2. Now I'm going to go past that line or through that yellow line. How many spaces do I want to go? 2 spaces. The same number of spaces so that it's nice and mirrored. There's K prime. Who's got my coordinates for K prime? 2, 4. That's right. 2, 4. Then we go over to J. We're again going to count to the right. How many spaces do we have to go for J until we hit that line of reflection? 4 spaces. 1, 2, 3, 4. So we're going to keep counting. 1, 2, 3, 4. Make a dot right there. J prime is now at 4, -2. And finally, for point L, how many spaces do we have to count over for point L? Just 1 space. So we're going to count past that line, just 1 space, make a point, and call it L prime. Who's got my coordinates for L prime? Osase? 1 what? -3. There you go. Let's go ahead and connect those 3 lines, or sorry, let's connect those 3 dots together to get our image triangle. And hopefully we can again see how this image has been mirrored or flipped across that line. There's my original triangle. I'm going to flip it across, totally turn it over, and boom, that's where we land. Okay, we start right here. It's my pre-image. We're flipping over the vertical axis, just like that, and we land right there at my image. J prime, K prime, L prime. Now, something to note here with this triangle, right? My bottom line of this triangle was sloping down to the right. But now my image triangle is sloping up to the right because we flipped it around. Okay, point K is still up at the top in both triangles, but now instead of being on the left, point J is on the right. Instead of being on the right, point L is on the left. We flipped it around. Hopefully you guys are seeing that. If not, we'll talk about it when we get worksheet 47. Let's fill in some blanks down here with our vocab. Go ahead and flip over to your vocab chart for me real quick. You're already there? Good. Look at you. So in that previous problem, triangle JKL is the blank of triangle J prime, K prime, L prime in the transformation above. What's the vocab word that's going to go in that spot? Osase. reflection. Very close. That's going to be our second one. But triangle JKL is the blank of triangle J prime, K prime, L prime. Ida, what do you think? Pre-image. There we go. JKL is the pre-image of J prime, K prime, L prime. Which is called a reflection because of the way the figure... I'm sorry, I messed up. Flips across the y-axis, which is a straight line. These two triangles are blank, Tina. Image? Close. Let's read on. They're blank, meaning they're the same exact size and shape. Breeza? Congruent. There we go. All right, meaning they're the same exact size and shape. We write triangle J prime, K prime, L prime, Tina in what? Prime notation. Good. So that we know that this triangle is the blank of triangle JKL. Who's got my last one? Anybody? Karina? Image, exactly. There we go. I'll get those rich tickets written when you guys are working. Let's go ahead and get started.